In this second part of the lab, we will do the calculations for the percent of water in Epsom salts, and also the amount of water in terms of mole, that X that is surrounding the formula. So in this case, we have the Epsom salts crystals here. You can see that they are shiny crystals, okay? And we are going to compare this appearance with the appearance that we have after heating. We put the glass rod and the beaker on the balance, and we are going to tar the balance or zero the balance. And then we will place the crystals in the beaker. So by difference, we have 5.01 grams of the Epsom salts. That is without or before heating. What we are going to do next is to take this one and begin heating, okay? And you are going to see that the fog is going to begin forming. Actually, you can even hear the sound of the water boiling that is contained in the crystals at the beginning. So we are going to continue heating it up until all the water is drawn out. The same as before, we have to be sure that we do not overpass 600 Celsius. That's why we use a hot plate instead of a Bunsen burner. So we are sure that the sulfate in the magnesium sulfate contained in the Epsom salts is not going to decompose. You can see how the crystals disappear, and now we have a clumpy substance, okay? That is because there is some water like gluing the compound all together. We're gonna see what happens after we finish the heating process. After more or less 10 minutes of heating it up, the water is going to leave completely, and we will see very small clumps that we can break and allow the rest of the water to go out, but you cannot see crystals anymore. It's going to be a powder, okay? So this is what we call the anhydrous substance without water. So we are going to let it cool down a little bit, and then we are going to measure the mass of the substance again. We have a mass of 2.51 grams. We are going to continue heating up several times to assure that the number that we get is a constant number, and not only that, but there is no more water left. We continue heating up, and we couldn't get a number lower than 2.44. So that is going to be our last value for the anhydrous compound.